So hey guys, how are you feeling here in Cadiz today?
It's good. It's a nice city to be. Lovely weather as well.
Your first time here?
Absolutely, yep, first time. Yeah.
And you're giving a talk as well.
Yeah, we're going to talk about maths used for programming and creativity.
How mathematical ideas, the things you're going to talk about, is it extensible to commercial software, the thing you said in your abstract?
Absolutely is. I hope we can show some examples in our talk, but we think that well-designed software has a consistent architecture, and oftentimes this architecture is something you can take from a mathematical domain. So one great example is the MapReduce, these big data processing platforms. We can look at them as mostly working over what are called monoids. So you make this abstraction of a monoid, and then you can very easily use a system with just different monoid instances. So it's a bit of sort of techno babble there, but the basic idea is, there's a mathematical abstraction at the core of the system. That's a very important commercial system.
What he said, yeah. So one of the sort of ideas of our talk is that these mathematical patterns can be used to make software easy to reason about. Just a simple equation can be easier to reason about than something that's not well defined. But they can also be used as playgrounds for creative ideas as well.
Yeah, that was the second question I was going to make to you actually. So do you think everything has this mathematical basis? I mean, in your talk you're going to relate this mathematical basis to visual arts, music, etc. Do you think everything has this is extensible to everything?
I'm not going to make a bold claim that everything has, but I think the idea is, well, you've heard that restrictions enable creativity. So like all the best comedy movies are the ones that had no money, and they don't have any money, and they had to improvise, and then they made a really funny movie. And you hear about people like doing great art because they were, near a beautiful river, and the river inspired them, and they made this completely different thing that's not a river, but they were inspired by it. So there are sort of patterns, and abstractions, mathematical abstractions, give us systems in which we can work. So, for example, one of the examples we give in our talk is building pictures by just tiling things. You can add images together in different ways, and you can produce all these different patterns. And like all the beautiful tiles we see all around Cadiz are examples of this kind of thing. So it can be creatively inspiring.
Wonderful. And what's your opinion, Noel?
I'm going to be a bit bolder than Dave, and I would say that mathematics is basically using a formal system to describe something. So we've talked about ideas coming from mathematics, but that means we're taking the ideas that somebody else has generated to describe something that they were interested in. So maybe like numbers and arithmetic are a basic example of developing math to describe something you're interested in. You can go the other way. You can create your own maths. You don't have to use existing maths. So if you're interested in some particular domain, I don't know, maybe dance or something like that, then you could develop a mathematical system to describe it. Maths is really just formalism, and anyone can create formalisms. So it might be difficult to capture everything of interest in your formalism, and your formalism might not cover everything that people do that they call their particular art form, but you can certainly capture the bits that are of interest to you. So I think, yes, you can do maths anywhere, anytime, any place.
Thank you for your time, guys.
No problem, thank you.
Thanks very much, cheers.